Okay, so here is more interesting probability examples. So we did a couple of these in class. Um, I've updated a couple of these problems. Um, in particular, let me go ahead and just choose this red one. I changed this number to 0.32. I've also uploaded this on Canvas, so if you want to take a the newest get the newest worksheet, you can have it. But you can go ahead and do these problems if you'd like. So I updated the first problem, and also I rewrote the last problem, number 4, especially if you're in my Monday, Wednesday class. I rewrote this entire problem because it didn't make any sense when I first wrote it. So what I really want to focus on is we did the first two in class. I want to be able to do the last two here, so that way you know what we're doing. So here is number 3. So number 3 says a study found that 48% of college students have laptop computers, and 47% do not have desktop computers. So it was also found that 13% have a desktop computer and no laptop computer. So part A, what we want to do is fill out the contingency table given the information. Okay, so let me go ahead and just use a different color. Um, so what we really want to do, we want to basically have all of this information that they give us and fill it in on this entire contingency table. So the first sentence says that 48% of college students have laptop computers. Okay, so first I have to look for laptop. So here is laptop. So that means that regardless whether they have a desktop or no desktop, these 48% of students have a laptop computer. So 48%, it's going to go here. Here's 48%. Or if I want to write it in decimal, it's going to be 0.48. Okay, so that's where laptops should go in the total. Okay, we also know that 47% do not have desktop computers. So for no desktop, this guy is no desktop. I'm going to go all the way at the end to the total, and that's going to be how many have no desktop computers. So 47%, or in other words, 0.47, have no desktop. Okay? What else do we know? We also know that 13% have a desktop computer and no laptop computer. So here the keyword is and. All of the ands are going to be right here in the center. Okay? Because you can see here is laptop and no desktop, desktop and no laptop, no desktop and laptop, and then no desktop and no laptop. So all of the ones that I put a red dot, that's where all the ands are going to be. So let me go ahead and get rid of this. So 13% have a desktop computer and no laptop. So desktop is right here, no laptop is right here. So if I were to kind of like bring them together, 13% is going to go right here. 13% or 0.13. Okay, so desktop computer and no laptop. Okay, so now all we have to do is fill out everything else. So one thing that we do know is that the whole percentages should equal 100%. Or if I put that as a decimal, 1. Okay, so now what we got to do is kind of like work backwards. So if I know that this whole thing should be 1, and I know that this top part is 0.47, well, how much more do I have to add to 0.47 to get 1? So if I do 1 minus 0.47, I'm going to get 0.53 or 53%. 0.53. You can also work with the percentages. 100%, 47%. How much do I have to add to 47% to get 100? 53. Or you can just subtract. 100 minus 47 gives me 53. Okay, we're going to do the same thing for this guy right here. Okay, so here's 48%. There's 100. So if I take 100 and I subtract it from 48, I'm going to get 52% or 0.52. All right, now let's look at this middle one with no laptop. So I know that this is 13%. The bottom part is 52. So if I take 52 and I subtract 13, I'm going to get 39. So this guy right here is 39% or 0.39. Okay. And now we have these last two. So let's look for this guy right over here, the first one. So what should I add to 13% to get 53%? So I'm going to take 53 subtracted by 13, and I'm going to get 40. So this guy right here is going to be 40%, or 0.4. Okay, and now for this one, I'm going to just use this this whole column. So I have 40%, and there's 48. I need to add 8% to get to 48. So it's going to be 0.08. Okay, and you can see that if I can add all of the different rows and columns, it should equal to whatever I want it to equal. Okay, so that's basically what it is for part A. So for part B, what is the probability that a student, a selected, has a laptop or desktop? So we want to figure out the probability that this particular person has a laptop. Let me write L for laptop, or desktop, D for desktop. Okay, so if you see here, the key word is going to be or, and or means the addition rule. Okay, so what is this going to be? So that means this is going to be the probability of laptop plus the probability of desktop minus the probability of laptop and desktop. Okay, so what is that going to be? So what is the probability of getting a laptop? Okay, so laptop is this first column, laptop. That probability is going to be this 48.48. Okay, plus the probability of desktop. Well, desktop is right here. So I'm going to look at this row. That's going to be this 53%, or 0.53. Minus the probability of getting a laptop or a desktop, which is going to be this middle part, which is going to be minus 0.4. Okay, so I'm going to go into my calculator, 0.48 plus 0.53 minus 0.4. What I'm going to get is 0.61. Okay, so that's my answer for that first problem, or 61% if you want to write 61%. Okay, now the next problem says, given that a student has a desktop computer, what is the probability that the student has a laptop? So what is the key word here? Well, the key word in this case is the word given. So we are given that the student has a desktop computer. So we are restricting everything from just desktop computers. So how many desktop computers do we have? So if we look at desktop, it's out of this 53%. So out of this 0.53, which is in green, okay, we want to figure out what is the probability that the student has a laptop. Okay, well, from these 53%, how many of them have a laptop? This 0.4. So it's going to be this 0.4 right here, this guy. Okay. All right, so what is this going to give me? So let's go ahead and put it in our calculator. 0.4 divided by 0.53. And let's round to 3 decimal places. So it's going to be 0.755. Okay, approximately. So let me just change this to approximately if you want to. Okay, so that's going to be the probability of that part. Okay, so using this contingency table, we're able to solve all of these things. Just make sure that you look for the keywords. Okay, alternatively, yes, you could have used this formula: probability of B given A is equal to probability of A and B divided by the probability of A. You could have used this formula if you want to. You would have gotten exactly the same thing. Okay, all right, so now let's look at the last problem. Okay, so this problem is a new problem where you actually have to completely delete. I had to update it. So here it says, at a small Midwestern college, 60% of the students are female. It was also found that 19.2% are male students and not liberal arts majors, and 61.6% are liberal arts majors. So construct a contingency table below. Okay, so here I didn't give you the contingency table because I think I ran out of space. So let me go ahead and just quickly write it out. Okay, so let's see, making sure that there's nice. Okay, so what I'm gonna write here, let me go ahead. It doesn't really matter where you want them to write it. So I'm gonna write total here, and I'm gonna write total here. And then let's assume here that um, for gender, it can only be males and females. So females and males. You can choose it to write it in the columns if you want to. And on the top, you're going to write liberal arts major. So I'm just going to write L for liberal arts. And I'm going to write NL for no liberal arts. Or you could have just used L complement if you want to. Doesn't really matter. Okay, so L just stands for liberal arts, and NL means no liberal arts. F stands for female, M stands for male. Okay, and we know that all of this should be out of 100%. Okay, or 1. Okay, so let's fill this out. So it says at a small Midwestern college, 60% of the students are female. So where's that 60% going to go? Here in the total. So 60% goes here, or you can write 0.6. Okay. So it was also found what? So it was also found, let me write a different color. It was also found that 19.2% are male students and not liberal arts majors. Okay, so that 19.2% is going to be for male students, males is right here, and not liberal arts, which is going to be right here. So this is going to be this 19.2%, or you can just write 0.192. Okay, that's where that one's going to go. Okay, and what else? What else do we know? So we also know that 61.6% are liberal arts majors. So it says nothing about gender. So that one's going to go where liberal arts is going to be. So here's liberal arts. It's going to be, let me just write it, 0.616. It's going to go right there. Okay. All right, so now what we got to do is figure out where all of them go. So let's start with female. So if I know that 60% are female, how many of them are male? Well, that must be 40%. Okay, or 0.4. Okay. So here we have that this last row, I have 6.616 to get to 100 or to get to 1. I'm going to take 1 and subtract it 0.616, and what I'm going to get is 0.384. Okay. Then I'm going to work with this column. Okay. So this number is going to be this number 0.384 minus 0.192. So 0.384 minus 0.192. That's going to give me another 0.192. Okay. And now we just need to figure out what liberal arts and the liberal arts in females and liberal arts in males. So I'm going to take this 0.6, subtract it to 0.192. That's going to give me 0.408. And then I'm going to take this 0.4, subtract it to 0.192. That's going to give me 0.208. So if you were to add all of this up together, you will get exactly what you will be able to get the solutions in the total. So if I add this row, I will get 0.6. If I add this column, I will get 0.616. Okay, so that's my contingency table. And now let's look at the last problem. So here we want to figure out, so given that the student is a liberal arts major, what is the probability the student is male? Okay, so we are given that the student is a liberal arts major. So that's a given part. So we are given that, that's the denominator. So given that the student is a liberal arts major, so liberal arts, that's 0.616. Okay, so of this liberal arts majors, we're only looking at that column. What are we looking for? What is the probability that the student is male? Okay, well, how many males are in here? Just this guy. So that's going to be 0.208. Okay, so let's go ahead and divide these out. So it's going to be 0.208 divided by 0.616. And what I end up getting, let's round to 3 decimal places, 0.338. Okay. And that's going to be my solution for that problem. Okay, so these problems are very self-explanatory. On an exam, this is something that would be very, very good to test you on. And just make sure that you really be able to figure out all these different probabilities by subtracting it from the total. Okay, and then be able to answer questions with conditional stuff like given that, or maybe an or statement.